Hello students, this is Sudeep Yadav from Spectrum Chemistry, and students, if you are first time visiting to my channel, so please like and subscribe my channel and press the bell icon to get a best explanation of NCERT book class 10th subject science. And students, in this video I will discuss with you chemistry. And student, if you are watching this video, so please go to my playlist and watch the previous 6 part of this chapter, by which you can create a better understanding for this chapter. So students, today we are going to discuss about the salts. So let's start students. The chemical form from common salt means which kind of the chemical we can form from the common salt. So let's start students. Sodium chloride. This is the name of the common salt. Sodium chloride is an ionic compound in which the sodium and chloride ions are in the ratio of 1:1. It is commonly called table salt, common salt, or halite. Means the mineral from form of common salt. So this is known as the halite. Now next, it is the salt which is mainly responsible for the salinity of the seawater and for the extracellular, and for the extracellular fluids, which is present in many multicellular organisms. It finds its application from household to industrial purposes, means it having the multi-purpose, means the salt is a multi-purpose thing or the compound. Seawater is a major source of the salt, means this salt we can get from the sea, that is the ocean. The chemical formula of sodium chloride is NaCl. Now next point that is very important, the occurrence of sodium chloride. So from where we are getting it, so we are going to discuss it. Mostly all the chemical compounds which consist of chlorine or the sodium is usually derived from salts. It is distributed abundantly in nature. Salt is a major ingredient of the dissolved material in the seawater. Pure salt can be obtained from mineral halite. Sodium chloride is obtained by mining the deposits, and brine solution is obtained by passing water into the deposits. So the term is here, that is a brine. What is brine? So brine is a solution of, that is a saturated solution of the salt. So brine is a saturated solution of the salt. Hence the salts get dissolved, then the solution is dumped out. Now next, how we can recover it? So evaporation of the seawater. Means if you want to get it from the seawater, so how we will get it? So we are going to discuss here. Evaporation of the seawater is one of the major processes used to obtain salt and is most widely followed in countries like India. The crystals obtained usually consists of impurities such as calcium sulfate, sodium sulfate, etc. Means these kind of the impurities will exist in the salt. So pure salt are obtained by dissolving the salts with little water and filtering the solution. So this was the process by which we were recovering it. Now next, preparation of sodium chloride. How we can prepare it? So however, sodium and chlorine, when the sodium and chlorine will respond to each other, means when both will be react to each other, to generate a substance that is familiar to nearly everybody in the globe, that is sodium chloride or table salt or common salt. These all are its respective names. Next, Properties of sodium chloride. What will be the properties of sodium chloride? Let's see. It is easily soluble in water and partially soluble or insoluble in other liquids. They are white crystals which do not have an odor but possess a taste. In its aqueous state, NaCl acts as a good conductor of electricity due to the free movement of the ions. And next point, it has a melting point of 801 degree Celsius and boiling point is 1413 degrees Celsius. So its melting point and boiling point will very high. Why? Due to the electrostatic bond is existing in between two particles, that is the sodium and chlorine. Okay, now next, uses of the sodium chloride, where we are using it. Okay, so let's see students where we are using it. It is widely used in food industries as a food preservative and as a flavor enhancer. It is a major raw material in the industrial manufacturing of various chemicals such as sodium carbonate, this is very important, sodium hydrogen carbonate, this is also very important, etc. This salt is used in the glass production as well as in cold countries. It is used to prevent the build-up of ice on roads, bridges, etc., which is important for safe driving conditions. So these all were the uses of the sodium chloride. Now next, its structure. This is very important. Okay, so here you can see its structure in the crystal, means crystal lattice. This is also known as a crystal lattice. Okay, so in the lattice, how the particles of the sodium chloride will arrange inside the crystal lattice, you can see in this picture. Now the compound, which compound will form from the sodium chloride. So this is the first compound which we can form from the sodium chloride, that is the sodium hydroxide. Okay, so let's discuss on the sodium hydroxide. Passing electricity through brine solution. And what is the brine? I have already stated you what is brine. Okay, so passing electricity through brine solution, that is an aqueous solution of the sodium chloride. This is a saturated solution of the sodium chloride. It decomposes to give chlorine and sodium hydroxide. So means on electrolysis of the sodium chloride, we will get sodium hydroxide and the chlorine gas. The process is termed as the chlor-alkali process. The term chlor for chlorine and alkali for the sodium hydroxide. Okay, so chlor-alkali process we can explain as alkali as a sodium hydroxide. We are using alkali for the sodium hydroxide and chlor for the chlorine gas, because when you are electrolysis will done for the sodium chloride, it will convert into sodium hydroxide and the chlorine gas will evolve. So this is the reason behind it. This process is also known as chlor-alkali process. Chlorine gas is given off at the anode. Okay, hydrogen gas is given off at the cathode, and sodium hydroxide solution is formed near the cathode. The reaction take place is as follows. So let's see student what are the questions, but first of all you have to see the apparatus and what will be the setup by which we can do this process. So this here is a setup. Okay, and you can see in this setup there is a battery, there is a key, okay, and there is a 2 electrodes as well as the vessels in which we will do this process. Okay, here is a aqueous solution of the sodium chloride, and at the cathode you can see here hydrogen gas will evolve. Okay, and at the anode you can see here that is chlorine gas will evolve. Okay, so this is the setup by which you can understand that how this process will going on. Okay, now let's see what is the equation? So here equation is given. So when the sodium chloride plus water will electrolysis process will takes place in the solution. Okay, means when the electrolysis will conduct in the solution, at that time the sodium hydroxide and chlorine gas as well as the hydrogen gas will evolve. Now next, which reaction will takes place at which electrode? So let's see student, the negative cathode, that is the negative cathode electrode reaction for the electrolysis of the brine, that is sodium chloride solution. So let's see at the cathode which reaction will takes place. Okay, the negative cathode attracts the sodium positive, that is Na positive, okay, and H positive ions. Means whatever the positive ions will be evolve during the electrolysis process, these all will move towards the negative terminal, that is the cathode. Only the hydrogen ions are discharged at the cathode. So here a term you can see, that is the discharged. Discharge means it will lose its charge here. Okay, it will lose its charge here, means this is the discharged. Okay, so how it will be discharged? Let's see. The more reactive metal, the less readily its ion is reduced on the electrode surface. And how it will be discharged? Let's see. The hydrogen ions are reduced by the electrons gain, means here at this terminal what will be happen, the hydrogen ion, that is the H positive ion, which are already deficient of the electrons, okay, they will get electron. Okay, here they will get the electron and they will reduce here. Okay, so H positive ion, how it will be reduced? So it will gain electron at this electrode, and after this process it will be reduced here. Oh, how it is reducing? Means H positive having the deficiency of the electron, and at the negative terminal it will be get one extra electron, which will be gained by the H positive ion, and by this process it will be reduced here. Okay, molecules at the negative electrode which attracts positive ions. So this equation by which you can understand how it will be going on. So here you can see this process as like, here is a 2H positive. Okay, and for 2H positive, what will be the number of the electrons? We are having the need to reduce it. So we are having the need of the 2 electrons. Okay, and after the gaining of 2 electrons, it will convert into H2, that is the gas. This is the gas. Okay, so this is the process which will takes place here. Okay, and another equation, what will be the another equation? Let's see students. Here you can see there is a water molecule, sorry, here's a water molecule. Okay, and when the water molecule will also gain 2 electrons, okay, so it will convert into H2 plus OH negative ion. Okay, so this will be takes place here. Okay, so you can see here now at the positive anode, that is the anode, okay, electrode, that is the anode. So the positive anode electrode reaction for the electrolysis of the brine sodium chloride solution, that is, okay, the positive anode attracts the negative hydroxide, means whatever the hydroxide ion will form in the above reaction, sorry, okay, so you can see here the hydroxide ion which is forming here. Okay, so it will attracts toward the positive anode. Okay, and chloride ions from sodium chloride, only the chloride ion is discharged here, means here will be the 2 anions, one will be the chloride ions and second will be the OH negative anion. Okay, so both will be attracted toward the positive anode, but here only one particle, here only one ion will discharge, that is the chloride ion. Okay, the chloride ion will oxidize here. Okay, so you can say at the anode the oxidation will take place, and at the cathode the reduction will take place. And you can form a rule also, that is N C R and P A O, that is the PAO, and here is a NCR. N means negative and C means cathode, R means reduction. So at the negative terminal, that will be cathode and the reduction will be takes place. Similarly, if we talk about the PAO, so it will be represent for the positive, means the PAO will be the positive terminal, and this positive terminal will be known as the anode. Okay, and here what will be the reaction will takes place? The oxidation reaction will takes place at the positive anode. Okay, so this is the short trick by which you can understand it easily. Okay, so now you can see here how both are discharging. Okay, how both will be discharged, means chlorine will discharge only at the positive terminal, and the second one, that is the sodium, that is the OH negative, will not discharge here. Okay, only chloride ion will discharge here. So let's see student, only the chloride ion is discharged in appreciable quantities, that is it is a preferentially oxidized to chlorine. Means it will convert into gas after the losing of the electrons. Okay, now the chloride ions are oxidized by electron loss. Okay, by the electron loss, the to give chlorine molecule at the positive electrode, which attracts negative ions. So here you can see the reaction. Okay, now hydroxide ion, how it will be react? The hydroxide ion with the uncharged sodium, that is the Na positive. Okay, not the uncharged. Okay, here is some typing mistake you can say. Okay, sodium ion forms sodium hydroxide, means after the discharging of the H positive or the Cl negative, here the two particles will remains. Okay, in the container, that will be Na positive and second one will be OH negative, and both having the opposite charges, so they will interact to each other and they will convert into neutral form, that is a base. Okay, so here sodium hydroxide will form. So this is the process by which sodium hydroxide will form. So I hope students, you must